Well, good morning and welcome to another weekly instructional lesson video. This video is entitled Proportions, and I'm excited to announce that we are on to our second unit. But at the end of this video, I will remind you that those that are still working on the first one, you need to continue to finish and work on that unit before you move on to this one. So again, the idea of we're progressing through our classes, and I know we're moving forward, but you will still be working in that unit. The first unit is due today, so this unit will be started tomorrow, but I wanted to start a new video for the first unit to introduce it, kind of get the ball rolling a little bit, and there will be no more video checkpoints in the first unit. So this one is going to start the new one, which again starts tomorrow. And our learning target for this unit is I can describe how to represent and calculate proportions from different real-world examples. So again, what we're going to look at is the idea of proportions and what that means. We've kind of introduced it in the last unit a couple times, but this is going to get pretty specific with what that word means. So again, at the end of the lesson, my goal is for you to say this statement with some clarity and some confidence that you know exactly how to represent and calculate proportions. As we move forward, in your lesson, I think I write down, give me a notice and a wonder about what is happening in this photo. So if you could take a second, pause the video, go to that lesson plan, and write some things down in the engage section on this picture. So hopefully you're able to write some things down and notice maybe some things that are happening. And here we have a recipe for what we call a super cake. I'm not sure exactly what that is, or it sounds tasty. It sounds actually pretty amazing. And I might maybe try to make it. I don't know. But if you look at from the super cake to a smaller version of that super cake, based on how many people are going to be there, we see numbers on the left changing to different numbers on the right. And again, we're kind of looking at how they're changing, why they're changing. And what we say is we can use proportions. And you might have heard this word when you deal with food, right? They get a proportion of that food, or a portion of that food. But we're trying to adjust a recipe in order to feed the appropriate amount of people that will be there based on a smaller version of the original or a bigger version of the original. Maybe we need to make more because we have more people. But we use the idea of proportions to help us adjust, all right, a recipe to be able to do that. So when we look, what should I know? We already know that fractions, what fractions look like and what ratios look like. And actually ratios can be written as fractions. All right. And what we should know about these two is that those numbers have a relationship. We talked about fractions, right? If we're going to increase a fraction by 2, when we find, when we reduce fractions, if we're dividing by a number, it's divided by the same number top and bottom. If I were to increase that fraction by 2 and I times it by 2, I have to time the numerator and the denominator by 2. The ratio, same thing. If I were to change it, I need to change both numbers by the same amount that I'm changing it by. They both have a relationship in that sense that they both change by whatever operation I'm using by the same number. So again, we know what a fraction looks like and we know what a ratio. So how does it apply to proportions? But if you look to the left, you see that we have two fractions that equal each other. So what we say is it's a pair of equivalent fractions or ratios that equal. And why I put the examples on the outside is to show you that a proportion is an equal sign, not a multiplication sign. So on the right, I put an X. That's not a proportion. That's simply just multiplying fractions. Doesn't mean they don't have a relationship. It's just we're multiplying. But in a proportion, they equal each other. All right. So in the left there, AB, or again, we use variables because we don't know numbers, equals CD. So those two fractions have a relationship. All right, they're a pair of equivalent fractions. They equal each other. And they have, again, they equal. That's a key word to kind of use there. And in the middle, you can kind of see an example of how it's solved and we use this idea of cross multiplication to be able to check to see if this proportion is actually equivalent. And if we notice 4/8 equals 8/16, if I cross multiply, they both end up equaling each other. So we say that proportion is equivalent because it works. So those fractions are equivalent to one another using the idea of proportions. So something else you need to remember is with proportions is that the labels need to match up. So if you look to the left for me, we notice that inches is on top and then feet will need to be on the bottom. So when we have proportions that have labels, they need to match up, right? So if inches is on top and I go to create my second fraction to the right, inches needs to go on top. If I'm dealing with, I don't know, we'll say since it's Halloween, candies per bag, and I go to make a proportion to a second fraction, candies goes on top here, and bag goes on the bottom. I know it's terrible writing, but whenever we do proportions, the labels need to match up. All right, the second one is we cross multiply to solve it. Look back in the previous example where they use cross multiplication, where in this example, I will be cross multiplying 50 by 30 and 20 by x. All right, and I use these little tunnel circles, I call them tunnels, that kind of keeps everything together. So I'm going to multiply those two sets of numbers based on cross multiplication. And in this instance is not like the first example. The first example that we looked at would be an idea of checking to see if two fractions are equivalent using proportions. In this example, we're looking for a missing number or part of the fraction of the proportion using proportions to solve for a missing number. So in this case, if we were dealing with inches and feet and we have 30 inches, we will know how many feet that would be, and what we can use is this idea of proportion. So we cross multiply and then we solve for the variable or the unknown like we usually do. And in this case, we get the final product of 75 feet. And again, we could take that 75, plug it in for the x, and we could go ahead and actually cross multiply again to check to see if those fractions are equivalent, to make sure that we did the correct calculations. All right, so we could do what was in the first example after we solve for x in this example. So again, some things reminded: labels need to match up, cross multiply to solve, and if there is a variable, we need to solve for that unknown to get an answer. So as we move forward, let's take a look, and we kind of already kind of sort of hit on this a little bit, but we're going to kind of do the same thing here. As we're going to look at some numbers. So again, if we have something like, I don't know, we'll say x over 2 equals 5/8. Okay, let's actually change that to 4, let's say 4/8. So if I was saying, what does the x equal in this problem? So what I do is I would draw my tunnels to say that I'm going to cross multiply. So what I would say is 8 times x is just 8x, and that equals 4 times 2, which is also 8. Then the next step is to solve for the variable. Noticing that 8 is multiplying x, I divide by 8 to get rid of it. And then 8 divided by 8 on the other side becomes 1, because with equations, what we do to one side, we always do to the other. Same operation, same number, and we get 1. So if I were to go back and check this problem, 1/2 equals 4/8. I would again cross multiply to get 8 equals 8. These are equivalent fractions. So this is just an example of how to solve fractions or solve missing ones or checking them using this idea of proportions. And some examples, again, you might have labels So again, you have to understand that the labels need to match up top and bottom when you're looking at those kind of things with this idea of proportions. So as we move on, why do I need to know this? Well, here's the thing. To find out what I don't know from what I do know, right? We use proportions. And if you notice in the examples that we worked on and looked at, even the unknown, we can use what we know to find out what we don't know, right? Using this idea of proportions, we find answers. So again, an idea of this would be like a recipe. If you notice this recipe, it calls for 3 cups of orange juice for every 4 cups of fruit punch. So 3 and 4 would be that fraction or that ratio and would equal whatever else is in the problem. So if you look, she's trying to make a large batch, so she's increasing her recipe. How many cups of fruit punch will be needed if 12 cups of orange juice are used? So if we have 3 cups of orange juice and 4 cups of fruit punch, the question is how many cups of fruit punch will be needed with 12 cups of orange juice? So if we go back here for a second and kind of look at this, if we have 3 cups of OJ and 4 cups of fruit punch, and we said we need to increase our recipe using 12 cups of OJ to identify how many cups of fruit punch. So again, the labels match up top and bottom in order to be able to solve this problem. So what we would do is we would cross multiply. 3 times x would give us 3x, and that's going to equal 4 times 12 is 48. And then we divide by 3 because 3 and x are multiplying. And what we do to one side, we do to the other. And then we end up saying that 43 or 48 divided by 3 ends up being, I do this off the top of my head, 18 would be 16. So 16, if we go back to our problem, we would say that the recipe would call for 16 cups of fruit punch to make those 12 cups of orange juice to enlarge or make this batch of recipe larger. So where do we use proportions? More than you think you know. When you're doing recipes, your parents will say, well, we have more people coming. We need to increase the recipe. We're using proportions. You may not draw it out like we did, but this idea of proportions is being used more frequently than you think that you are. So hopefully you're able to kind of see how that's used and why we need this, again, to find out what I don't know from what I do know. So what should I be focusing on as we end this video today is, again, the explore, explain, evaluate, elaborate, and express. So again, the explore is you exploring additional resources to kind of enhance your understanding. Our explain is our weekly Padlet of discussion material. The evaluate, I'm actually going to get you onto the first checkpoint, even though your PACE guide says, hey, work on the power focus areas, which you need to. I would like you just to do the first checkpoint as a check for understanding from this lesson that you understand this idea of proportion. So you already have one checkpoint down, all right? And then you can go back and work on your power focus areas. And the elaborate is a giant pumpkin activity since it is Halloween or October season. Hopefully you enjoy that, be able to find some things with recipes there. And then again, the idea of express, being able to reflect and learn about yourself through this lesson. So as we end, some important things to remember is that you need to finish the scale drawings first. Remember the idea of progress. We're not going to jump forward to this unit if you haven't finished. Some kids and some students finish at different paces, and that is okay. And we want to be able to respect that. So you can continue working on that unit and finish it before you move on to this one. If you are moving on to this one, you can start on the power focus area of proportions and be able to start into that and look at the PACE guide for more information. Continue to set goals. It is crucial that you set goals, especially when you start a new unit and you're not as busy as you were ending the other unit. You kind of get relaxed. So make sure that you're setting goals and working in this unit and getting off to a good start. Again, the due date for this is November 15th. That seems like so far away, but again, we need to keep that in the back of our mind as things do creep up fairly quickly, as we noticed with the first unit. So keep that in your mind. So again, if you have any questions, please let me know. And we're going to have a good start to this unit. And I hope you guys have a good rest of the week.